Hello and welcome to Maths with Jacob. This lesson will focus on Pythagoras' theorem. Pythagoras. Pythagoras was a Greek mathematician who lived about 2,500 years ago. It is believed that he made one of the most important mathematical discoveries of all time. Before we state the discovery, let us look at a typical right-angled triangle. So here's a triangle, of course it has three sides and three angles. It's called a right angle triangle because this angle here is a right angle, which means it's 90 degrees. We have A, B and C for the lengths of the sides. This side is called the hypotenuse because it's opposite the right angle. So sides A and B are the other two sides. So there's the hypotenuse because it is opposite the right angle, and there's sides A and B. This is the actual theorem, so Pythagoras' theorem. If we look at the picture to the right, Pythagoras said the following. Here we have the right angle triangle, and we've made a square here from this hypotenuse. We've also made a square from each of the other two sides. So this is Pythagoras' theorem in words. The area of the red square equals the sum of the areas of the blue and grey squares. So the area of the red square, which is C units, is equal to the sum of the areas of the blue square. The blue square has sides of A units, and the grey square, where we have B units. In other words, that area is exactly the same as the sum of those two areas. So another way of saying what we said on the previous slide is the square on the hypotenuse equals the sum of the squares on the other two sides. So the square on the hypotenuse is C squared. The sum of the squares on the other two sides are A squared plus B squared. Hence the famous formula C squared equals A squared plus B squared. Let's have a look at a simple example which will enable us to find the hypotenuse when we're given the other two sides. So the above example will illustrate how Pythagoras' theorem can be used to find the hypotenuse of a right angle triangle when we are given the other two sides. If we follow the theorem as stated, we have the square on the hypotenuse, which is x squared, equals the sum of the squares on the other two sides, 3 squared plus 4 squared. Going down to the next line, 3 squared is 9, 4 squared is 16. We add those two together to give us 25, so x squared equals 25. So x is the square root of 25, so it has to be the positive square root of 25 because we're looking at a distance. We're not interested in a negative distance, we just want a length. So x is 5 centimetres. So in other words, the hypotenuse is 5 centimetres long. Another example which allows us to find the other side. The above example will illustrate how to find an unknown side when we are given the hypotenuse and one of the other sides. So we have the hypotenuse, one of the other sides, but we can find the other one. So the theorem says that the square on the hypotenuse, which is 10 squared, equals the sum of the squares on the other two sides. So m squared plus 8 squared equals 10 squared. Simplifying those two terms, we get this line. If we subtract 64 from both sides, that's just a simple solution of the equation, we get that line. We end up with m squared equals 36, so m equals the square root of 36, so m equals 6 centimetres. So that's a right angle triangle with 6 centimetres, 8 centimetres and 10 centimetres. So this video has given us a brief introduction into Pythagoras' theorem, which is a theorem attached to right angle triangles with respect to the lengths of the sides. We've seen Pythagoras' theorem in the form of an equation, and we've also done a few examples to see how to actually use the theorem.